Alright, so our next topic is vectors. Now, before starting this topic, you should be aware or have an idea about your O-level vectors. Why are vectors so important? Vectors are basically used to model many situations in the world around us. They are used mostly by engineers to ensure that the buildings are designed safely. They are used in navigation purposes of planes and boats. Uh, And there are countless examples of the use of vectors to model the movement of objects in maths and physics. Few examples of vectors are displacement, velocity, acceleration. These are all our vector quantities. They are essential to describe the position and location of few objects. Now, you in your O levels you have done vectors in 2D. In this P3 we are going to look at vectors in 3D as well. Before this topic, you should have a good understanding of simple coordinate geometry, and so that simple coordinate geometry before you start working with vectors, because you will be able to make comparison between the coordinate geometry that you had previously studied and the vector geometry that is going to be introduced in this chapter. If you remember, vector has both magnitude. What is magnitude? It's the size of the vector and the direction. Both quantities are required to uh, denote a vector. Okay, so movement basically means that a body has moved a certain distance in a given direction, and that is known as the displacement. If a person has moved from A to a point B, then that is the displacement of from A to B. This displacement is also known as translation because that person has translated from this location to this location. So if we are able to measure the length of this line, we are able to find the magnitude. Now, notation of vector, the starting point comes first and then the ending point, and the arrow is going to tell you the direction of the movement. So AB would means going from A to B. A is the starting point, B is the ending point. BA would mean opposite. B is the starting point and A is the ending point. Okay, now if this was 4 units and this is 3 units, 4 units in the x and 3 units in the y direction. If you were standing at point A and you had to go to point B, in the x direction you travel 4 units and in the y direction you travel 3 units, then the AB vector will have a column vector as 4, 3. 4, 3 means that move 4 units in the x direction and 3 units in the y direction. However, BA is going to be opposite. For BA, you will have to move first the 4 units to the left and then 3 units to the down. So this is how BA is written as a column vector -4, -3. You can observe over here that AB and BA, since they are opposite and equal vectors, they are opposite vectors. So AB is negative of BA. That is always true. So if I have PQ, then QP is going to be the negative of PQ. Is this clear?
Yes, sir.
All of this is basic. Now
Yeah.
let's see vectors in 3 dimension. This is x, this is y, and for the time being I'm making this as z. You can play around with the x's later, but right now I'm just showing you this orientation. Let's say you move certain distance in x, then you travel certain distance in y, and then you travel certain distance in z and reach a point in the space. So this means that you have traveled certain distance in x, certain distance in y, and certain distance in z direction. So if that's your origin, then if you join the origin and the vector p, we call this the position vector OP. The position vector is related to origin. This OP will have, now it's a three-dimensional vector, so it will have some unit in x, some unit in y, and some unit in z. If it is traveling in the positive x direction, so positive x component. If it is traveling in positive y and positive z direction, so positive component. But if particle p was somewhere over here, then obviously this is negative x, positive y, and positive z. So these values can change based on the location of p. Now you can also visualize this. The orientation could also be this when the x and y are down. Let's say this is x, this is y, and this is z. So if I move 2 units in the x direction, 3 units in the y direction, and 5 units in the top direction, so that's your point p. So p has a coordinate of x as 2, y as 3, and z as 5. If I join O with P, then the position vector OP is going to be 2, 3, 5. This is how it is going to be written as a column vector. Now in your O level maths, you knew how to calculate the magnitude of a vector. So when you had a two-dimensional vector, the magnitude of AB, this is the symbol for the magnitude, was given by the x component square plus y component square root. So if I had a vector AB that is 4, 3, then 4 square plus 3 square root, the magnitude comes out to be 5. Similarly, when you have a three-dimensional vector, so the magnitude of OP vector is nothing but the x component square plus the y component square plus the z component square root. Make sense?
Yes,
So
sir.
in this case, OP is going to be 2 square plus 3 square plus 5 square root. So 4 plus 9 plus 25, that is square root of 38. That is going to be the magnitude. Okay. Then you would have also done parallel vectors. Consider these few examples. Okay, this is vector A, this is vector B, and this is vector C. Now the arrow on the vector is going to give you the direction. So if the length of this line is half of this line, or you can say if the vector B line is twice of vector A, then you are going to say that the vector A is either you can say half of vector B, or you can say vector B is twice of vector A. They are the parallel vectors. Similarly, vector C is in the opposite direction, and if let's say the value was for C, let's say it's 3/4 of vector A, but in the opposite direction. So for the opposite direction, we are going to write a negative scalar number. So this, and this value all are the scalar numbers. So if the vectors are parallel, if two vectors are parallel, they must be scalar multiple of each other. The quantity used to scale a vector is known as a scalar vector. Scalar basically. So 2b vector is twice of vector A. So it's two times of vector A. So generally, you can say that two vectors A and B, if they are parallel, then vector A is lambda times vector B, where lambda is a scalar value. You can say scalar multiple or scalar value. So if this condition is satisfied, then you can show that the two vectors are parallel. And if you know that the two vectors are parallel, you can use this condition. Then you would have also done addition and subtraction of vectors. Okay. Okay, do you see the graph clearly?
Yes, sir.
If I give you two vectors A, B as 4, 2 and B, C as 3, 7, and I ask you to find vector AC. Now vector AC is the resultant vector. Vector AC is going to be the resultant vector of vector AB and vector BC. Remember this addition rule. Vector AB plus BC is going to be equal to vector AC. If these inner terms are same, then the resultant vector is just the outer letters AC. So you have been given vector AB, that is 4, 2. So if I take this as my starting point as A, to mark the point B, I'll have to travel 4 units in the X and 2 units in the Y from A. So 4 units in the X and 2 units in the Y. So that is my point B. This gives you vector AB. Then vector BC, for vector BC, the starting point is B and the ending point is C. So 3, 7. I'm just going to take this down. Yeah. To mark C, from B, I'll have to move 3 units in the X and 7 units in the Y. 1, 2, 3, 4, 5, 6, 7. So that is C. If you connect B and C, you get a vector BC. Now vector AC is going to be this vector. Okay. So I can find AC by calculation as well. AC was equal to AB plus BC. Vector AB is 4, 2 in terms of column vector. Vector BC is 3, 7. So as an end result, it's going to come out as 7, 9.
Yeah.
This is by calculation. Now, if you would have to pick up from the diagram, going from A to C would mean that you travel from A directly to C. So from A to C, you're going to travel 7 units in the x direction. 1, 2, 3, 4, 5, 6, 7. And then 9 unit in the y direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you understand this? The resultant vector
Yes,
is
sir.
going to be marked by double arrow. This operation is known as vector addition. Any questions so far?
No, sir.
Okay. If you get this, can you also tell me what is CA vector going to be equal to?
-7 and -9.
Very good. -7 and -9 because it's just the opposite vector.
Yeah.
Okay. Now, vector subtraction is basically the addition of a negative vector. So, for example, if I give you AB as 4, 2 and BC as 3, 7, but this time I want you to find AB minus BC. Okay, AB minus BC. Now, AB minus BC simply means from AB you add the negative of BC vector. What is the negative of BC vector? It's going to be,
-3, -7.
yeah, it's going to be CB. Yeah, either you can do like this. So if I draw this, starting point was A, 4, 2. This is my vector AB. Now I'm going to add the negative of BC. Negative of BC is going to be -3, -7. So from B, -1, -2, -3, and -7. I should have taken this up further. So negative, add the negative of BC. So negative of BC is going to be -3, -7. This is AB. Minus BC is going to be -1, -2, -3. 1, 2, 3, 4, 5, 6, 7. Okay, this is your CB vector. Now, if you join the two vectors using head to tail rule, then you can connect them and find the resultant vector. Okay, let's try a question now. P, Q, R, S is a quadrilateral. PQ vector is A, PS vector is B, okay, there's a point M on SR, on RS, and it's a midpoint. Okay, M is a midpoint. You have been given that PQ vector is A, PS vector is B, and PM vector is 1/4 of 2A plus 5B. ये given है question में. Part A says find an expression in terms of A and B for Sm. This is Sm vector. Sm vector means going from S to M. Now you need to understand the geometry. Going from S to M is same as taking the root from S to P and then from P to M. Going from S to M is same as saying going from S to P and then P to M. Do you understand this?
Yes, sir.
So Sm vector is the vector addition of Sp plus Pm. What is the vector Sp?
Minus B.
Minus B plus Pm is 1/4 of 2A plus 5B. So after solving this, what will you get?
1 second. Uh, 1/4B plus half A.
1/4B plus half A. Okay. So that means half A plus 1/4B. Okay, the next part says find an expression for QR. Find an expression for QR. Try this one. So if you want to find QR, you can take another route. You can first travel from Q to P, then P to S, and then S to R. Okay. Since you do not have directly QR, you can find QR by taking the alternate route Q to P, P to S plus S to R. So QR is basically the resultant vector or the addition of QP plus PS plus SR. QP is negative A, PS is positive B, and SR is going to be what? SM. M is the midpoint. So Sm vector is going to be half of vector Sr. So what is Sr going to be equal to in terms of Sm? If the vector Sm is half of vector Sr, then Sr is, can I say Sr is double of Sm?
Yes.
So what is, do we know Sm vector?
It's A, right?
Sm vector,
Like,
no, it's not a
I
parallelogram,
think
it's
it's
just a
half.
quadrilateral. Sm vector is 1/2 A plus 1/4 of
Oh,
B. So half A plus 1/4 of B. This is what QR is. Okay.
Yes, sir.
Okay. Now you have been asked in the next part. You have been asked to describe this quadrilateral PQRS. What shape is it?
Uh, QR is longer than PS.
Justify your answer. So you need to identify the shape. We know it's a quadrilateral, okay, but it cannot be a parallelogram because we see that the vector p, q and s are not parallel. But are the vector p, s and q are parallel?
Yes,
How do you know that?
because uh,
Basically qr, remember what was the condition for vectors being parallel?
QR is like something of B. It's a fraction of B.
Exactly, so qr is 3 upon 2 times of b, and what was b? B was ps. So I can write QR is 3 over 2 times of PS. So yes, these two lines are parallel. These two vectors are parallel, but the other two vectors are not parallel. So what is a shape that has two sides parallel, whereas not the one pair of sides parallel, but the other pair is not parallel? What do you call that shape?
Um, I don't remember, so
It's the trapezium. Because in square, rectangle, parallelogram, rhombus, opposite sides are also equal and parallel. But in this case, in trapezium, two sides are parallel, whereas the other two sides are not parallel.
yeah,
So this shape is a trapezium. Okay.
yes, sir.
Any problem? Any query in this?
No, I got it.
Okay. Okay. If I give you a as 4 3 and b as minus 3 4, ठीक है, I want you to find the magnitude of A, the magnitude of B, and the vector A minus B. This is part A. This is easy, right? Do you need any my
Yes,
help in this?
sir. No, I got it.
Okay, this was a two-dimensional vector. Now I'm giving you an example of a three-dimensional vector. Okay, so for the first part, it's just going to be 4 square plus 3 square square root. That is 5.
Right.
For the second part, it's going to be minus 3 square plus 4 square square root
That's also
16.
fine.
That's also 5. Now the vector A minus B. vector A minus B is going to be
7 and minus 1.
7 and minus 1. Right. Also find me the magnitude of A minus B vector. So that is going to be 7 square plus minus 1 square square root. 49 plus 1 square root of
5 root
50.
2.
Square root of 50 is 5 root 2.
Yeah.
Okay. Now the next part says find the magnitude of the vector p plus q. So to find the magnitude of this vector p plus q, I must have the vector first, p plus q. So I'm going to add the two vectors. Now to find p plus q magnitude, that is going to be 4 square plus 8 square plus 5 square square root.
That's root of 105.
Root 105. Correct. Now the next thing we are going to discuss is the concept of unit vector. Basically, a unit vector is any vector that has a magnitude of 1 or the length of 1. It is the notation of a unit vector is like this. If A is a vector, then A, there's a small hat on A, and this is read as the unit vector in the direction of A. To find the unit displacement vector for a particular direction, you find the magnitude of that vector and divide the vector by its magnitude. So for example, if there is a vector p that has the x component, y component, z component, to find p hat, you first will be finding the magnitude of the vector p, that is simply x square प्लस वाई स्क्वायर प्लस जी स्क्वायर स्क्वायर रूट. ठीक है, आपके पास मैग्नीट्यूड आ जाएगा. फिर आप what you are going to do is you are going to divide the each component by the magnitude. So the x component is going to be divided by the magnitude, the y component is going to be divided by the magnitude, and the z component is going to be divided by the magnitude of p. The resulting vector now is going to be called the unit vector. So for example, if you're asked to find the unit vector in the direction root 5 2, it's a 2D vector, then the for this vector, what you are going to do is you're going to first find the magnitude of this vector. I'm naming this vector A. So if A is root 5 2, then A magnitude is going to be root 5 square plus 2 square square root, which is 5 plus 4 9, that comes out to be 3. So then A hat, the unit vector, is going to be root 5, the x component divided by the unit magnitude, and the y component divided by the magnitude. This is the unit vector. Later we are going to write them in terms of I, j and k as well. Similarly, if I extend the concept to 3D vectors now, if AB is 3 4 1 and BC vector is 11 minus 2 minus 1, and the question says find AC hat, the unit vector in the direction of AC. So first of all, you are going to find the vector AC. Okay, the solution will have, first you are going to find the vector AC. How am I going to find the vector AC?
AB plus BC.
Right, AB plus BC. 3 4 1 plus 11 minus 2 minus 1. 14, 2 and 0. Now I'm going to find the magnitude of the vector AC, that is 14 square plus 2 square plus 0 square square root. What is this coming out? 14 square plus
10 root 2.
square root of 200?
Yeah.
10 root 2. Yeah, 10 root 2. Now the unit vector AC hat is just the vector AC divided by the magnitude of AC. So magnitude is 10 root 2. The vector AC was 1420. Either I can represent the unit vector in this form, or I can divide 14 by, or you can also write your answer as 14 upon 10 root 2, 2 upon 10 root 2, 0 upon 10 root 2 is 0. Either you can leave your answer like this. Do you
Okay.
understand this?
Yes, sir.
Okay. I'm going to send you a worksheet on differential equation for further practice. You can try those questions over the week. In tomorrow's class, I'm going to continue with the vectors.
Okay.
Okay.
Thank you.
You're welcome. Allah
That's
Hafiz.
it.